Welcome back to Hipposphere. You are in a soft-lit corner of the internet where science slows down, where curiosity is allowed to arrive on its own schedule, and where the most puzzling ideas can be held like smooth stones in the palm of the mind. If this is your first time, I am glad you are here. Settle in. Let your shoulders drop. If you like, you can tell us where you are listening from and what the time is for you right now. Tonight we are going to listen to a very old question with new ears. We are going to ask whether time, as we feel it, is an illusion. Not a trick in the sense of a magician, but an appearance that arises from deeper structure. The way a rainbow is real to the eye, yet not a solid object in the air. We will move through physics, through the way our brains make a timeline from sensation and memory, and through the quiet places where equations seem to fall silent about any moving now. The words will be careful and unhurried, the images simple. The aim is not to win an argument, but to learn how to rest in the question. Notice your own sense of time right now. Perhaps there is the fading echo of what you did today, and the outline of what you will do tomorrow. Somewhere in your awareness, there is a little arrow that points from past to future. It is bound up with memory, with expectation, with your pulse and your breath and the clock on a nearby screen. When we say time feels like it flows, we are speaking to this arrow. It is the shape of how experience is stitched together. The idea that time might be an illusion asks whether that flow is a property of the world or a property of the stitching. Physics, which is our most careful way of asking nature questions, has an interesting relationship with time. The laws we use to describe falling apples, colliding stars, and swarms of particles are almost all symmetric in time. Play the film backward and the equations do not flinch. Yet we do flinch because broken eggs do not repair themselves on the counter and waves do not unbreak upon the shore. There is a tension here, but it is a gentle one, like a string held between two fingers. On one end is what the mathematics says. On the other end is what the kitchen says. We will start by letting the word illusion breathe. Call an illusion anything that is systematically different from the deeper reality that gives rise to it. This does not mean unreal in the everyday sense. A mirage is an illusion, yet it is born from real light bending in hot air. A sunset that floods the clouds with pink is an illusion of the Earth's atmosphere, yet the color is an honest report of photons scattered into your eyes. When we ask whether time is an illusion, we are asking whether the flow, the privileged present, the absolute sense of before and after are like the pink of a sunset, real to us because of how we stand in the light, but not a fundamental ingredient of the cosmos. In human life, time is intimate. It is the rhythm of childhood and aging. It is birthdays, anniversaries, work weeks, storm seasons, long weekends, and late-night talks that seem to open and close a little pocket in the day that we step into together. It is the difference between a wait that feels endless and a laugh that arrives quickly and leaves too soon. If we whisper that time might be an illusion, the whisper touches grief and memory and hope. For that reason, we will be gentle. We will step carefully between the science and the feeling, and we will let each inform the other. It helps to remember that our measures of time are inventions. The day is the spin of Earth. The year is our path around the sun. Seconds, defined today by the vibrations of cesium atoms, are the steadiest heartbeat we could arrange. A human agreement refined into a world standard. The calendars and clocks that shape our lives are bridges between the sky and our plans. The bridges are strong, but they are still bridges. Under them, a river moves. So how could time be an illusion if the clock on the wall is both trustworthy and extremely precise? The short answer is that clocks do not measure an independent river flowing through everything. They measure intervals along paths in the world, and those intervals depend on how the path bends and how fast it is traced. If that sounds abstract, it will soon become concrete. For now, imagine a trail map. The lines are there on paper, but your stride and the slope make your minutes. Time, in physics, turns out to be stitched to movement and gravity in ways that bend our familiar sense of a single shared now. Before we climb into these ideas, release any need for a tidy conclusion. It is enough to understand a few structures clearly. It is enough to learn to sit beside the river and notice that what we call flow may be a pattern that arises when we look from inside. The question of whether time is an illusion is not aimed at removing wonder. It is aimed at letting wonder change shape in our hands. Take another breath. Let the room be quiet. In a moment, we will begin at the beginning and ask what time meant to the first thinkers who tried to measure it, and how the simple act of keeping time on Earth set us up for the astonishment of Einstein's insights. For now, we move softly to that early ground, where sundials watched shadows slide and pendulums taught us how to listen. In the old squares of ancient cities, time revealed itself as moving shadow. A gnomon, a simple stick, cast a line on stone. As the sun crossed the sky, the line curved, and in that motion people found hours. It was a local kind of time, made of sunlight and weather. When clouds gathered, the hour dissolved. Water clocks answered with a gentle trickle from bowl to bowl. Then came sand and the slow, granular hush of an hourglass. Time was something you could pour. Centuries later, pendulums began to beat. Galileo noticed that the swing of a lamp in a cathedral took the same time no matter its amplitude. He measured with his pulse and imagined a clock. Huygens made that clock real. The pendulum gave us more than precision. It gave us a faith that the regularities of the world could be harnessed, and that time might be the most regular of them all. On ships, accurate timekeeping became a lifeline. John Harrison's marine chronometers turned the rough chaos of sea travel into solvable geometry. If you could carry Greenwich noon with you, you could find your longitude in the rolling blue. Philosophers argued while the gears turned. Isaac Newton described absolute, true, and mathematical time as something that flows equably without relation to anything external. It was like a cosmic stage clock, indifferent, steady, universal. Gottfried Leibniz objected. He said time is not a thing that exists on its own. It is an order of succession, a way we relate events. In his view, there is no container of time. There are only happenings and the relations between them. For a long while, the Newtonian view sat easily with daily life. It gave us a firm sense of a shared present. The idea that two events separated by distance happened at the same moment had a common-sense feel. It fit the telegraph wires that began to lace the continents. Towns set their clocks to the railways. Noon became a negotiated moment. Across the globe, time zones turned local suns into a social mesh. Then something delicate and strange interrupted. Light, that brightest messenger, would not behave. Experiments suggested that light speed was the same for all observers, no matter how they moved. Imagine you and a friend racing toward a beam of light. You would expect to measure it as slower, since you are running to meet it, but you do not. You both measure the same speed. This is not a small oddity. It is a guide rope that leads into a new way of seeing. Albert Einstein followed that rope. He asked what had to give way to let the speed of light be constant for all observers. The answer was the familiar structure of space and time. He proposed that measurements of lengths and durations depended on how you moved, and that the equality of light speed was stitched into this dependency. In special relativity, simultaneity is not a universal concept. The question of whether two distant events happen at the same time does not have a single answer. It has as many answers as there are observers with different states of motion. Think of two lightning bolts striking a long, straight track, one at each end. A person standing in the middle sees both flashes arrive together and declares the strikes simultaneous. Another person gliding by in a smooth train will not agree. For them, the flash from the front must chase them, and the flash from the back must meet them. They will declare a different simultaneity. The world allows both accounts. There is no cosmic referee who peels away the relative to reveal the true present. There is only a network of events and the light that travels among them. Einstein's colleague, Hermann Minkowski, gave this idea geometry. He fused space and time into spacetime, a four-dimensional fabric where events take their places as points, and where the path of a person or a particle is a world line. Replacing the picture of a single flowing now, there was a block, a hole, in which all events are laid out. This block does not ripple with the movement of a universal present. It just is. The past and future exist in the same way that the rest of the landscape exists beyond the hill you are on, whether or not you can see them. Moving is not sliding through time. It is tracing a path through space-time, and the time measured along your path is your proper time. If this sounds like an elegant story with no teeth, the teeth are in the clocks. Take two identical clocks. Move one quickly, or lift it higher in a gravitational field, then bring it back. The clocks will disagree, and the disagreement will match the geometry of space-time. This is not a rumor. Commercial airliners have flown atomic clocks around the world, and the difference was observed. Muons created high in the atmosphere live longer as they race toward Earth, because their internal clocks are dilated by their speed. The satellites that guide your phone account for time dilation due to both their motion and their altitude. Without this correction, your map would drift kilometers each day. The block is not a philosophical game. It is the silent scaffold beneath daily navigation. In this picture, the flow of time is not a property of the world. It is a property of our experience as we move along our world lines. a sense of a privileged present, a universal now that marches forward, does not appear in the equations. What appears are relations between events, the causal structure given by light. What appears is a grammar that defines which events can influence which others. The now we feel is local and personal, like a lantern that lights only a small circle around our feet as we walk. Our instincts, raised on pendulums and calendars, might object. We do not experience life as a four-dimensional block. We experience unfolding. This is where the question of illusion takes an interesting turn. The block may be accurate at the level of space-time geometry. The flow may be real at the level of minds that make sense of signals. An illusion is not a mistake. It is a lawful appearance. We can honor both, the tenseless structure of physics and the tense texture of experience. There is another ingredient to add, and it has to do with why we remember the past and not the future. It connects with broken eggs and sunsets, with heat and cooling, with the slow drift from order to disorder that seems to give time a direction. This is the arrow of time, and it will shape our next steps. The laws may be symmetric, but the world we occupy is not. In the calm of that difference, something like flow begins to whisper. If you have ever watched cream curl into coffee, you have seen the arrow of time. The spirals mix, the swirls fade, and the drink settles into a tawny sameness. You can stir to speed the process, but you will not see the coffee unmix on its own. Behind this behavior is a statistical truth. There are more ways for the molecules to be distributed evenly than unevenly, so it is overwhelmingly likely that a system will move from a state of low disorder to high disorder. In physics, we call this property entropy. The second law of thermodynamics says that in an isolated system, entropy tends to increase. Ludwig Boltzmann taught us how to think about entropy not as a substance, but as a count of possibilities. A neat stack of cards can be arranged in fewer ways than a shuffled deck. The neat stack is special, rare, low entropy. The shuffled deck is typical, common, high entropy. When we see a broken egg on the floor, we do not doubt that it was once whole, because the number of arrangements that look like a splattered mess is vast, and the number that look like a tidy egg is tiny. The second law is not a rigid command. It is a profound bet, and the odds are so heavy that the bet might as well be law. Yet the microscopic laws that move the molecules do not care about forward or backward. They are time symmetric. Loschmidt, a critic and friend of Boltzmann, pointed at this. If the laws are symmetric, why do we see a definite direction? The answer that emerges is subtle. The laws are symmetric, but the conditions at the beginning are not. If the universe began in a low entropy state, then the most likely evolution from that state is toward higher entropy. The arrow we experience is a consequence of that special beginning. This idea is called the past hypothesis. In the calm of that assumption, the increase of entropy becomes a steady wind that fills our days. Arthur Eddington named this wind the arrow of time and suggested we trust it. If something contradicts the increase of entropy, he said, your theory will be in deep trouble. The arrow is not only about mixing cream. It is about heat flowing from hot to cold, about stars burning hydrogen into helium and heavier elements, about brains forming memories. Memory making is a physical process that increases entropy. Storing information leaves a trace. The act of remembering the past is aligned with the direction in which traces accumulate. This alignment seduces us into thinking the arrow is a fundamental feature of time. It may instead be a feature of the universe's biography. While thermodynamics gives time a direction, relativity keeps its grip on the geometry. General relativity deepens the story by showing that gravity is the curvature of spacetime. Mass and energy tell spacetime how to curve. Curved spacetime tells mass and energy how to move. Clocks in strong gravity run slower than clocks in weak gravity. Light climbing out of a gravitational well loses energy and shifts red. The geometry is serene and without a preferred knell. Within that serenity, stars age, galaxies evolve, and entropy grows. The two pictures are compatible. There is no contradiction between a tenseless block and a directed arrow. One is the stage. The other is a pattern of plays on that stage. To feel the tension and the harmony together, imagine a library. In this library, every book that could be written, about every moment that could occur, already sits on the shelves. The library is not arranged by a town clock. It is arranged by relationships. Some books are next to others because one can lead to the next through the causal structure that light permits. Now place a reader in the library. The reader moves, opening book after book. Their path through the stacks is shaped by physics and by choices. They carry a growing notebook of memories. The library does not flow. The reading does. For the reader, the present is the page that is open beneath their hands. Experiments have given the geometry enough weight to rest on. In 1971, Joseph Haffel and Richard Keating flew cesium beam atomic clocks eastward and westward around the Earth. Upon return, they found the clocks disagreed with the reference clock in a way that matched relativity. Eastward, faster than Earth's rotation, time was lost. Westward, slower, time was gained. GPS satellites live at the edge of this precision. Engineers must adjust their timing for the fact that satellite clocks tick faster due to weaker gravity and tick slower due to their orbital speed. The corrections are not cosmetic. They are essential. The city map in your hand is a quiet proof that time behaves like a path length in a curved space, not like a universal river. Relativity also reshapes simultaneity in ways that trouble our sense of a shared now. You and a friend can agree on the order of events that can send signals to each other. Cause still comes before effect in every local frame. But for distant events with no possible influence between them, observers in different states of motion can disagree about their ordering without any contradiction. This is close to the heart of the idea that the present is not an absolute layer that slices the universe. It is a local horizon that moves with each world line. The present is like the sky you see above your head. It is shared in spirit, but not identical in detail. If the equations are silent about flow, and the arrow rides upon the specialness of the past, where does that leave the feeling that time passes? It leaves it where feelings often live. In the brain, in the body, in living systems that must predict and act. A creature that cannot remember and anticipate cannot survive. The act of threading sensation into a continuous story is not optional for a mind like ours. It is the way we stay upright. It may be that the felt flow, the bright present, and the sense of becoming are constructions as necessary and lawful as the rainbow. They are illusions in the precise sense, born from real processes, not faithful pictures of the wider world. We have not yet mentioned quantum theory, and it sits here like a quiet animal at the edge of a clearing, watching. Quantum mechanics, in some of its forms, writes equations that do not include time in the usual way. Whole universe descriptions can be timeless. Yet within them, observers can recover the appearance of time by using parts of the universe as clocks to read other parts. The idea that time arises from correlations rather than existing on its own is one of the most delicate we will touch. It will wait for us in the next part, where we will walk a little further into the forest and listen for the heartbeat of moments emerging from entanglement. Imagine you stand before a lake at night. The surface is still, so still that the stars seem to rest on it. You toss a small pebble. Ripples widen. If you did not know there was a stone, you might say the lake has begun to flow, that it has acquired a direction. But the lake itself is not going anywhere. The ripples are relations. They are patterned changes moving across something that stays. This image is a way to approach the idea that time could be the pattern, not the underlying substance. In certain formulations of physics, the world at its most complete description does not evolve in time. The appearance of evolution arises from the relations among parts. The Wheeler-DeWitt equation is one such formulation. It is intended to describe the quantum state of the entire universe. In its simplest presentation, it looks like a single quiet equation with no time variable at all. That can be unsettling. How can a timeless equation describe a world where stars are born and die, where children grow, where rivers cut their beds? One answer, suggested by Page and Wouters, is that time is not a universal parameter, but an emergent measure of change obtained by using one part of the universe as a clock to track another. Choose a subsystem to be your clock, then ask how the rest of the universe is correlated with it. As the clock changes, the rest changes in step. The joint state is timeless. The story we tell is a sequence of correlations. Carlo Rovelli and others have carried this relational idea further. In relational quantum mechanics, the properties of a system are not absolute. They exist only relative to other systems. Time becomes a tapestry woven from interactions. If nothing interacts, there is no story of before and after to tell. The thermal time hypothesis adds another thread. It proposes that time flow can emerge from the statistical state of a system, from the way probabilities sit inside a large ensemble. When a system is far from equilibrium, the direction of increasing entropy defines a time parameter. Time is born from the way the world is distributed over its possible configurations. In loop quantum gravity, geometry itself is quantized. Space may come in grains, tiny loops of area and volume. Time, in that picture, is not a smooth stream, but a bookkeeping of transitions between quantum states of geometry. Causal set theory imagines the fabric of spacetime as a discrete web of events ordered by cause and effect. In both cases, the continuous picture we draw at large scales is an emergent smoothness. The clock on your wall and the flow you feel are shadows of deeper combinatorial dances. These ideas are speculative, but they are not wild. They are careful attempts to be faithful to what we know, while extending it past the places where our equations break. Black holes and the Big Bang make time fragile. Inside a black hole, the roles of space and time can switch near the singularity. Near the beginning of the observable universe, our best theories are pressed to their limits. Some cosmological models propose a bounce, a contraction before expansion. In others, quantum fluctuations seed the structure of galaxies. In some of these settings, there is no universal time that covers everything. There are only patches, stitched by light and gravity, and a sense of evolution that belongs to observers who carry their own clocks. While physics considers timeless formulations, neuroscience watches the brain as it builds time from pulses and predictions. There is a window called the specious present, a brief duration, perhaps a few hundred milliseconds, within which the brain gathers sensory events into a single experienced moment. We do not experience razor-thin instants. We experience a little echo chamber where sounds and sights are blended and ordered. The kappa effect shows that the perception of time between events can be stretched if the spatial separation is larger. Chronostasis can make the first moment after a saccade seem longer, as if the second hand on a clock had hesitated. The oddball effect makes rare stimuli feel longer than common ones. These are not errors. They reveal that the brain uses context and expectation to build time. Memory and prediction are twins. The same neural machinery that reconstructs the past generates imagined futures. The hippocampus, so important for memory, participates in this simulation. Brains are prediction engines. They try to minimize surprise by anticipating the next input. In a predictive framework, perception is the brain's best guess about what is happening now, given what has just happened and what usually happens. The flow of time, in this view, is the running sync between incoming data and a rolling model. The present is a negotiation. The future, sketched in pencil. The past, inked with traces that can still be edited by recall. Our language holds time in a particular way. We speak of it as a resource to spend or save. We talk about timelines and deadlines, yet we also use spatial metaphors. We look forward to events and look back on them. Some cultures picture the future behind them, unseen, and the past ahead, seen and known. This plasticity suggests that the brain's maps for time borrow from its maps for space and action. When a physicist says the present is not absolute, it resonates with a deeper truth that for living beings, the present is a constructed horizon, useful and real in the way tools are real. So is time an illusion? It depends on what we are pointing at when we say time. The block of space-time has no moving spotlight of now. That is an illusion of perspective, necessary for navigation by beings who experience. The arrow that points from fewer to more mixed states is not an illusion. It is a statistical tendency grounded in the universe's initial conditions. The flow we feel is an illusion in the precise sense that it is a lawful appearance, just as color is an appearance born from wavelengths and receptors. Illusion here does not diminish. It places. There are puzzles left on the table. Quantum entanglement knits distant systems so that their properties are correlated in ways that defy classical intuitions. Yet the causal structure remains. Signals do not outrun light. Does entanglement hint at a deeper layer where time is less primary than information and correlation? Some researchers suggest that space itself may arise from entanglement patterns in a more abstract network. If space is emergent, perhaps time is too. The shape of now could be the shape of information flow within the universe-sized web. Let the analogies sit as small lanterns. The library of moments, the reader moving with a lantern of now. The lake that is still rippled by relations. The deck of cards that grows more shuffled in the dark. The brain that builds a present by stitching sounds and sights into a small cradle of experience. In that soft light, the idea that time might be an illusion is not a threat to meaning. It is a permission to see meaning as something we make inside a patient and timeless geometry. In a moment, we will step back from abstraction and ask what this changes in the way we live. If the universe is a whole, if the present is local, if the arrow is a tendency, if the flow is constructed, what does that invite in us? Not urgency. Perhaps a different quality of attention. Perhaps a kindness to the selves we have been and the selves we will be, each a page already somewhere on the shelf, waiting to be read by the light we carry. You are listening in a particular room or car or bed at a particular hour with a body that has its own rhythms. There is a clock in your chest, a clock in your head, a clock in the sky. Your suprachiasmatic nucleus, the tiny timekeeper in your brain, syncs to light and sets the pace for hormones and temperature. When you travel across time zones, it struggles, then settles. These clocks are as real as any pendulum. They matter deeply for health, mood, and memory. To honor the thought that time's flow might be an illusion does not mean ignoring your clocks. It means understanding them as ways your life is braided with the world, not as proof that there is a universal river carrying everything forward. Knowing that relativity guides GPS does not change your walk to the cafe. It just means the map in your hand is nested in a larger harmony. Knowing that entropy tends to increase does not make a messy desk inevitable. It invites you to see tidying as a small local reversal paid for by energy from breakfast and the sun. Knowing that the present is a constructed horizon does not make your feelings less true. It offers a way to hold them with gentleness. When grief returns from a past loss, it arrives now. When joy from an old memory blooms again, it blooms now. The block picture does not flatten these experiences. It lets you imagine that the moments that mattered still exist in the library, even when your lantern has moved on. If time's flow is an appearance, then urgency can sometimes be softened. The pressure to outrun the clock relaxes into attention to the page that is open. This does not dull responsibility. It sharpens presence. A conversation feels different when you believe this moment is not escaping, but simply joining the others that already are. Craft becomes patient when you think in chapters rather than seconds. Rest becomes honest when you let your body set the metronome. The thought that the future already exists can feel cold, as if it removes the space for choice. It need not. In the block, your path includes your choices as part of its shape. The you who decides tomorrow is as real as the you who decided yesterday. From within, you still must weigh and choose. Freedom, on this view, is not outside the structure. It is the structure of you, a pattern that includes your reasons and your cares. The lived reality of choice does not vanish when we adopt a tenseless perspective. It becomes a feature in the geometry, a curve written by the forces of character and context. Life is not only physics, it is also story. Stories have arcs that point, beginnings that feel raw, and endings that feel full. When we say time might be an illusion, we do not mean that stories are false. We mean that story is a way of being a mind in a world that sits in a larger calm. The calm is not indifference, it is spaciousness. Your memories and plans are the way you sail that space. They are your ripples on the lake, your page turning in the library. You might ask what it gives to imagine time this way. It gives patience to learning. Physics becomes less a race to final answers, and more a walk where each view is appreciated. It gives tenderness to aging. The younger self is not gone so much as located elsewhere on the shelf. The older self is already within the library too, sitting in a later sunbeam, smiling. It gives a way to sit with regret. You cannot reach back to change a page that is already printed, but perhaps you can change the way your light falls on it, and the way the next pages are read by the same hand. There is also a quiet gratitude that can grow from the idea that the universe is not rushing. Stars are born and die without hurry. In the time it takes to breathe in and out, photons that left distant galaxies long before Earth had forests are arriving. Your breath, measured by your pulse, is part of a network of durations that nest inside one another. From atom to heart to planet to cluster, there is a hierarchy of clocks. The fact that they do not all agree is not a flaw. It is the signature of a rich geometry that allows beings like us to exist. If time is emergent, then change is not denied. It is located. It happens along world lines, in the correlations that build our sense of before and after. The illusion is not that nothing happens. The illusion is that there exists, in addition to happenings, a separate thing called flow that sweeps them along. What there seems to be, instead, is a patient, complete fabric in which change is woven, and in which the experience of passage is the track left by minds navigating. As you prepare to sleep, or to return to your day, you can hold both views at once. The physicist's calm block that contains all events. The human river in which we float, remembering and anticipating, loving and learning. The two are not enemies. They are different windows. You can let the windows sit at right angles and watch the light change on the floor between them. Thank you for joining me in this gentle wandering. If you found this time together restful and thought-provoking, you are welcome to subscribe to Hypnosphere. There is no hurry. We will be here, moving slowly, reading the shelves, listening for the soft logic of the world and the stories it invites us to tell.